It's late on a rainy Tuesday. You finally settled on the couch and you turn on your TV. Before you even search, there it is, a row of movie recommendations that perfectly match your mood. That spot-on suggestion didn't come from magic, and your TV isn't reading your mind. It's the invisible engine of artificial intelligence doing exactly what it was built to do. When we hear the words artificial intelligence, we usually picture something out of a science fiction movie, maybe a glowing android trying to take over the world. But the reality of what we interact with every day is much quieter and a lot more practical. The technology currently in our homes and phones is what researchers call weak AI or narrow AI. The name sounds like an insult, but it just means these systems are incredibly good at doing one highly specific, predefined task. You use this specific technology all the time. It's the voice assistant setting a timer in your kitchen, the GPS finding the fastest route around a traffic jam, and them streaming algorithms figuring out what you want to watch next. These invisible co-pilots seem smart, but they don't actually have any general awareness of the world outside of their programming, which raises an interesting question. How exactly do they learn to do their specific jobs so well? The answer comes down to a concept called machine learning. Instead of programmers typing out rigid, step-by-step instructions for every possible scenario, they build systems that can adapt and improve on their own. There are three main ways to teach these systems. The first is called supervised learning. Think of it like studying with flashcards. We give the machine a massive set of data where the answers are already labeled, teaching it to look at a specific input and map it to a known output. The second method is unsupervised learning. Imagine dumping a giant bin of mixed buttons on the floor. The machine looks at all this raw, unlabeled information and figures out how to group things by color or size, finding hidden patterns entirely on its own. The third way is reinforcement learning, much like training a puppy. The machine is placed in a trial and error environment where it tries out different decisions, receiving a digital reward when it gets things right and a penalty when it gets them wrong. Whether using labeled flashcards, sorting a messy pile, or guiding with rewards, the core goal is always the same: training the system to recognize complex patterns in massive amounts of data. As we get better at feeding these systems more data, the capabilities of the technology are rapidly expanding. To understand where we are on this timeline, consider that a few decades ago, the cutting edge of human computing looked like this: room-sized machines that helped put people on the moon. Today, a smartphone has millions of times that processing power. Yet, despite all that capability right in our pockets, every application we use operates strictly within the boundaries of narrow, single-task intelligence. The current frontier researchers are aiming for is called strong AI, or artificial general intelligence. This refers to a future system that can learn and apply knowledge across multiple, entirely unrelated subjects, matching our human ability to solve different types of problems all at once. Beyond that is a theoretical stage known as super AI. At that point, a machine's problem-solving ability would extend past our biological limits entirely. Watching hardware and code evolve this quickly brings up a natural question. If machines continue to grow stronger at processing information, what exactly is the unique role of the human mind? It is easy to look at these advancements and worry that human beings will eventually be replaced. But the reality is that biological brains and digital processors are built for entirely different kinds of work. This comparative chart lays out the exact differences. When you look at the middle column for machines, you see they are perfectly designed for high-speed, repetitive tasks. Their core strength is ingesting massive datasets and picking out patterns with high accuracy. Now look at the human column on the right. We excel at areas where machines struggle. We can draw accurate conclusions from sparse, incomplete information. We bring emotional and social intelligence to a problem, and we are capable of original, creative thought. We are moving toward a partnership where artificial logic handles the heavy data crunching, while human moral reasoning makes the final calls on how to use that information. This collaborative ecosystem is called augmented intelligence. This design philosophy prioritizes building tools that sharpen our own instincts and decision-making. You don't have to wait for the future to start taking advantage of this. You can apply augmented intelligence in your own daily life right now by following 3 simple steps. Step 1 is to identify the right tool. When you have a task that requires sifting through heavy amounts of data or repeating a tedious process, Recognize that you can delegate that heavy lifting to an AI system. Step 2 is to guide the machine. These systems aren't mind readers, so the more specific context and clear instructions you provide as inputs, the more accurate and useful the output will be. Step 3 is your own judgment. Delegating repetitive data tasks frees you up to focus on the high-level, abstract problem-solving that machines cannot replicate. At the end of the day, artificial intelligence is simply a powerful engine built to help us process a complex world, but it will always be human beings sitting in the driver's seat, charting the course.